I'd like to turn it over to Dan Miller, our encapsulator technology specialist. He'll be our presenter this afternoon.
Good afternoon, everyone, or welcome, whatever the time of the day or night it may be where you're at. We sure appreciate you joining us today. My name is Dan Miller. I'm an encapsulator technology specialist with Hazard Control Technologies out of Fayetteville, Georgia, USA. Um, Also with us today, who was speaking prior to me, Heather Emmett. She's going to be our moderator today, and she's going to make sure and uh, be the uh, person that hands out punishment to anyone who gets unruly. So, um, again, thank you for being here today. We will have a question and answer session at the end. You can place any questions that you have, and we encourage you to do so in the Q&A chat section. Um, but also in the chat section itself, we would sure like to know where you're located and your primary reason for joining us for this webinar today, what your primary concern or hazard is that you're following up on. So what we'll do is go ahead and get started. We have about 40 or 50 slides to go through in our presentation. Try to take a little bit less than an hour, but sometimes it runs over a little bit. So um, again, we encourage you to ask questions as you formulate them. Please put them in the Q&A, and we'll answer them one by one as we go. Um, in our company is called Hazard Control Technologies. We are located in Fayetteville, Georgia, USA. Um, we've gone from a small local chemical agent manufacturer to one that has a nation, or excuse me, a worldwide reach at this time. We have over 27 years of existence manufacturing the same primary chemical agent, which is F500 encapsulator agent, and um, it's ISO 9001 product, so it's been the same for many, many years and manufactured to the same standard uh, around the clock and around the globe. We have over 15 years of fire testing on lithium-ion batteries themselves, but many more on other agents, as well as environmental testing and uh, performance testing as well. We cover 6 continents, but pretty much wherever you're at in the world, our agent can be made available to you by reaching out to Hazard Control Technologies through our website, filling out a form, and we can get you in touch with the right distributor for your area. We provide fire suppression, vapor mitigation, and contamination control solutions. They're supported by our in-house team of specialists, engineers, firefighters, business owners, and their communities. So, one of the first things we want to touch on as we talk about our sprinkler and deluge system solutions and proportioning devices and our agent, which is F500 encapsulator agent, I want to let you know that encapsulator agent is not a foam. It's pretty much the opposite of foam. But due to the rise of concerns with PFAS and other issues with foam, there's been a lot of fluorine-free foam hitting the market and being developed more and more all the time. There are different formulations for fluorine-free foam, but it also has some significant limitations. Number one, just because it doesn't have PFAS in it, doesn't mean that it doesn't contain any harmful ingredients. There are many synthetic ingredients in most fluorine-free foams, especially the Class B fluorine-free foams that are made to replace AFFF. Um, and some of those agents are harmful in their own right to health and environment and other things. One of the other things is foam has never really been applicable to a flowing product or a spraying product or anything like that, what we call a three-dimensional Class B fire. And NFPA 11 even states that it's inappropriate choice for fighting three-dimensional flowing fuel fire hazards. So as we look at the performance of fluorine-free foams, this little video, I'll kind of talk through it. Um, but this video is of an actual fluorine-free foam test on liquid ignitable at an airport testing facility. And some of the things you'll notice about it and some of the things that were discovered about the fluorine-free foam formulations is it takes 1.5 to 3 times as much product volume to do the same work as the legacy AFFF to actually put the fire out, knock the fire down, and keep it down. Some of the other limitations are is that it doesn't set up that really robust bubble and good film over the liquid ignitable like the old AFFF did with PFAS in it on purpose. Um, so what you're seeing there, if you look really, really close at some of those bubbles, is there's fingers starting to reach out throughout that bubble pattern. And that's called tunneling and ghosting. You get tunneling under it, and it comes out on the other end somewhere and ignites on the other end. But what they've kind of determined from that is that fluorine-free foam, at least the formulations that they have tested, are not very good for high vapor pressure products. The high vapor pressure pushes the foam up off of the surface, allows some air in, and that air infiltration under the foam blanket causes the fire to grow and spread. It's also, it blows off the surface easily, which you can see in the video on the far end of the liquid pool. It's blown towards the uh, foam and left some of the pool open without foam on top. Um, so it just doesn't have the robust nature of the AFFF the way it did. So it's not very wind resistant, not good to high vapor pressure products, not good for three-dimensional fires, and it takes more to do the job of the legacy AFFF. So, um, some other hazards that have come along in the last several years. Automotive industry has changed. There's a lot of combustible metals, more volatile fuels, lithium-ion batteries, all of those things to improve performance, make the cars more lightweight, more durable, more economical, and more environmentally friendly. As we move towards uh, proposedly a net zero automotive industry. Parking structures, however, are increasingly housing charging stations, things to incentivize the use of electric vehicles. Um, and there's really no control put on where those electric vehicles are parked, other than if they want to charge, they'll park near the charging stations. But for the most part, there's no regulation on that and where they park. So we're looking at a situation that the NFPA has changed, as well as Factory Mutual has changed their uh, uh, standards and rules to where every parking structure now needs sprinkler protection, and the hazard class of the sprinkler of parking structure has gone up, so there has a higher sprinkler density required. Uh, in the face of that, plain water has never really been proven as successful on lithium-ion batteries. It's wildly inconsistent, and the hope is that at least the plain water sprinkler system can protect the infrastructure as the fire grows and hopefully burns out before it damages the infrastructure and or firefighters can get to it, make access to it, and put that problem out. But we're here to offer solutions to that today, so we'll be talking about that solution shortly. The aviation and aerospace industry, they're really making efforts to lower their carbon footprint as well. They're going to a lot of EV-powered ground support equipment. There's much more, as we know, cordless lithium-ion battery-powered equipment throughout every work environment. There's EVs parked in the parking garages at the airports. There's just a lot more lithium ion batteries throughout that industry. And as the the mobility of that workforce and the ground support equipment and everything that goes with it grows, so does the hazard of lithium-ion batteries in that environment, as well as the hazards they already had with the liquid ignitables and so forth. Electric power, energy storage, the power grid is all being made more green. We're using more renewable energy sources. And when we use those renewable energy sources that are active during the sun up hours and the windy hours during the day, that energy has to be stored. So these battery energy storage systems, attach them to the grid. Battery energy storage systems are simply a large bank of lithium-ion batteries storing many kilowatt hours per BESS unit. And as that energy is needed during peak hours, then the batteries are designed to make up that difference on the grid. Now that can be a large utility level power grid, but it can also be down to data centers with inside of buildings, for private companies, 911 centers, um, server farms, etc. So an uninterruptible power supply now may not have lead acid batteries in it. It may have lithium ion batteries in it instead. So another fire hazard that, because of lithium ion batteries, the the outcomes are different than they used to be with lead acid batteries when you do have a fire, whether that's an internally generated fire within the BESS unit or due to an external fire making its way or exposing the BESS unit. Either way, you have a much more intense and hazardous outcome because of the presence of the lithium ion batteries. The maritime and marine industry has really changed. A lot of the cargo is changing. There's a lot of cordless tools and devices and mobility devices going from point to point all over the surface of the earth via the maritime industry. The maritime industry itself is using lithium-ion power for certain features of their vessels. And then there's vehicles as well, going from point to point all over the globe. And some of these are in intermodal containers. Some are driven onto ro-ro ships, for example, like large floating parking garages. Um, so there's a big hazard there when it comes to the additive size of those lithium-ion batteries on board ships. The other thing is, we still have all the normal combustible and flammable liquids being transported all over the earth, like crude oil, for example. And back in late August, early September, the Sunion oil tanker was attacked and set ablaze by the attackers and burned for a couple of weeks while it was moved to an area that it could be more safely extinguished without the threat of attack. So those kind of attacks are becoming more and more of a possibility as political forces change around the world and so forth. Things that are out of most of our control, but we have to find a way to protect them. And as a matter of fact, the Sunion oil tanker was extinguished a couple of weeks ago, and it was extinguished with F500 along with CO2 to help below deck. So F500 was used in that extinguishment process. Warehousing and logistics. So when we think about warehouses, high rack storage, we're thinking about 30 to 40 foot high ceilings and what we call uh, uh, early suppression fast response or ESFR sprinkler heads that may not be up to the challenge of the things that are being stored on the racks of these warehouses nowadays, like the lithium ion batteries and pallets and pallets of tools and equipment and mobility devices. And then the material handling equipment itself that's being used within those warehouses is being converted over to lithium ion batteries as well. So you've got both the the somewhat static hazard of the things on the rack, and then the material handling equipment that's running around the warehouse as well could uh, present a problem at any point. And this can be due to a charging issue, a defective battery, even one cell out of thousands can cause the problem, or it could be due to a collision or a traumatic event that's traumatic to the batteries on a physical level. And when these lithium-ion battery fires occur, um, they tend to they tend to burst into flames rapidly, but sometimes they just emit vapors, and you can have a vapor cloud explosion prior to flaming combustion. And when that occurs, you more or less have a deflagration or an explosion, and then you have rapidly spreading fire. So in these cases, a sprinkler head that's 30 or 40 feet above the problem may not react fast enough on a lateral basis to keep up with the fire growth. Um, and definitely when it comes to the production of flammable vapors from a lithium ion battery that's in what I would call slow thermal runaway, as that vapor cloud builds, those ESFR closed heads are not reacting to that vapor cloud building. So that can present an issue in itself. So we're going to talk about a couple of those things as we go along, and how we provide a solution to that with F500. So our next slide is a video of F500 encapsulator agent, how it how it how it works in a solution of water to suppress fire. And I'm just going to let it play, and then we'll talk about at the end of it, we'll talk about what just occurred on the screen and what that means to fire suppression.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet, with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So as you look at that image on the screen, it's a cross-section of a water droplet that has been solubilized by F500 molecules. So as we proportion it into the water stream, that nonpolar tail causes it to self-dilute, rush apart, and then as it comes out of a nozzle in droplet form, it forms a droplet similar to what you see on the screen with the F500 molecules on the outside. The polar heads are on the surface of the water droplet. The non-polar tails are pointing out like the fuzz on Velcro. And then inside of the water droplet, it's also inundated with F500 molecules. But since the non-polar tails fear water, they're oriented the other way. So the hydrophilic heads are pointed outwards towards the water droplet, and then the tails are pointed inward, forming what we call spherical micelles. So the spherical micelles also trap carbons and hydrocarbons that would otherwise feed combustion. Since they're trapped inside of the water droplet, they're not available to oxidize, and they're not available to combustion or to feed combustion. There's several other features to it as well. It's got a surfactant quality to it, which allows the water droplets to be much smaller and to absorb heat better. and it absorbs heat through the nonpolar tails, through the heads, and actually into the packed spherical micelles inside of the water droplet. So it absorbs heat much more efficiently and effectively than a plain water droplet does, from 4 to 10 times, and sometimes even greater than that, depending on the makeup of the fuel package itself. So it's got a high molecular weight to it, so it travels through uh, upward thermal columns very, very well. As it strikes the surface of a liquid fuel, for example, it's going to encapsulate the carbons and hydrocarbons of that liquid fuel inside of the spherical micelles, neutralize that fuel, and turn it into an inert product. And then as it's flying through the vapor space towards the fire, it actually um, captures carbons and hydrocarbons out of that vaporous atmosphere. And due to the high molecular weight, it also does something we call interruption of the coalescence of free radicals. So free radicals come off of an incomplete combustion fire. And as they come off of there, they're looking to mate up with other free radicals and to restabilize into new compounds like benzenes, acrylenes, carbon monoxide, hydrogen cyanide, many different uh, carbonaceous compounds, some of which are toxic, many of which are flammable and help the fire grow. We're interrupting that process. We're cooling, we're encapsulating hydrocarbons. We're doing that all at the same time by these droplets flowing towards the fire. So this all happens instantaneously. It makes your same amount of water much, much more effective than it would have been if it were plain water. It helps us mitigate modern hazards. So unlike a foam, which is mechanical, just sits on the surface and does what it does to smother and eventually allow the liquid agent underneath to cool, the encapsulator works on a molecular level. It mixes with that fuel. It mitigates the fire on 3 levels. Uh, it takes away the flammability, the explosivity being, you know, a factor of the vapor mixing with oxygen in the atmosphere immediately above the fuel. It takes those things away. It cools, and it takes away the toxicity as well. It works on all 4 legs of the fire tetrahedron simultaneously. Uh, so it's taking away the fuel, it's hiding it, it's locking it up, it's hiding it from the oxygen, it's rapidly cooling, and it's interrupting that chemical chain reaction. So uh, it really, really is effective on many, many levels, all at the same time. And when you think about that base function of the F500 and the water droplet and the encapsulation of carbons and hydrocarbons in the spherical micelles, it does those same things to the toxins that would otherwise accumulate on firefighters' turnout gear, equipment, etc. So that really lends itself to health and safety overall. And actually, in 2022, community of Laval in Canada, a suburb of Montreal, along with the University of Ottawa, conducted a study on an acquired structure. They compared the polyaromatic hydrocarbon accumulation on firefighters' turnout gear after attacks with plain water versus attacks with F500. They measured that accumulation at the University of Ottawa, and they were able to show that there was a significant difference when F500 was in the water stream, that the accumulation of those harmful carcinogens was much, much lower on the firefighters' turnout gear. That same effect would happen with sprinklers and deluge systems as well. It really knocks down those vapors, that smoke. It lowers that concentration of the smoke in the atmosphere and improves the visibility. F500 is documented as a fluorine-free biodegradable water additive. It's non-corrosive. Um, and SGS, a Swiss company that does inspection, verification, and testing, um, uh, has tested it and has approved it for use in many, many countries as a safe agent. NFPA 18A is a relatively new standard. It was released in 2022, and it really defines what an encapsulator agent is, whereas NFPA 11 talks about foams and all of the working parameters of foam agents. NFPA 18A defines encapsulator agents and encapsulator agents specifically. There is a section in NFPA 18A, section 7.7, which is the testing criteria to determine whether an agent truly is an encapsulator agent. And in that test, it is applied to a pool of fuel. Uh, uh, an ignition test is conducted, and then 15 minutes later, another ignition test is conducted. It has to stay inert throughout. With F500, it is compatible with that. It was actually the standard that was pretty much named after this product after many, many years of trying, because it is different. It is not foam. It's not a wetting agent. It is very, very unique. There are some copycat agents out there. Whether or not they can pass this test, we don't know. The Section 7 point test is actually carried out on a battery of liquid ignitables, and it has to be that way to pass that test to be considered an encapsulator agent on more or less on the fuel uh, uh, that it's intended for in the end. So there's another section, Annex 4.3 and 18A, that talks about the specific effect and effectiveness of F500, or excuse me, encapsulator agents on lithium-ion batteries. So encapsulator agents under Annex 4.3 are recognized for many, many years of independent, successful testing on lithium-ion batteries. And again, that is based on the testing that HCT has done with independent organizations all over the world for over 15 years. We have many, many different companies currently using our agent and that have done testing on it. Many automotive manufacturers have done their own testing. Independent testing agencies from all over the world, like NIOSH, Kiwa, Heinrich Hertz Institute, DEKRA, NFPA, APLUS, uh, uh, many agents, again, many organizations all over the world have tested F500 and have found that its effectiveness is very consistent on lithium-ion batteries as well as other hazards that's been tested on. There are many private companies and things like racing organizations, for example, that use F500. The EV industry is no stranger to the race industry. As a matter of fact, Formula E racing in Sao Paulo, Brazil, used F500 for their safety. So in March of 2023, Formula E's track safety team safeguarded their Julius, I may mispronounce this, sorry, Julius Baer Sao Paulo E-Prix in Sao Paulo, Brazil, with our signature F500 TKO nozzles. They're just a 20 GPM or 75 liter per minute nozzle with the agent cup on them and the ejector built in. So they did the same in 2024. And it's also used in the Moto E World Cup for the motorcycle racing. You can see here it was used on a crash and in some testing to make sure that it would work for them. They adopted the agent and they're using it, with some of our European extinguishers with F500 in them. Got a little crash video here. Everybody likes a good crash video.
Tangled, and that's big off there. Look at that thing. Look at that thing. Hang on a minute, it's burst the airbag. They're going to red flag this, and that's red flag. Now
So you can see our
we've got special fire extinguishers on the
with
side of the pipe.
F500
There's a
in
green light and a
being
red
used
fire.
to
It's
cool
just,
that battery.
here's the meltdown sheet. This sheet here, they're not covering up because they're embarrassed. That they're going to.
The Model E World Cup, but Bradley Smith,
They're covering it
second,
with a
where we expect
blanket
to
to
see
try
him up on
to,
the podium.
exclude some oxygen. Doesn't look like it actually went into flames. It was probably precautionary, but F500 is used in the race industry now, especially in Formula E and E-moto racing. So Applus Laboratories did some testing on F500, along with a European partner of ours, to actually mimic a parking garage situation. Applus Laboratories is a world leader, a very large organization with over 26,000 employees worldwide and in 70 countries. They do a lot of testing around the world, and their test results are actually recognized by UL in many other countries as well. So the test that they conducted was called a tunnel safety test. But it was actually set up more to mimic a parking garage situation. So as you can see from the picture, the heads, the sprinkler heads, the deluge heads were lowered down to the typical level of a parking garage ceiling. The cars were parked. There were two cars parked side by side. The car that's a little bit elevated has a sizable lithium-ion battery system under it. That lithium-ion battery was put into thermal runaway, and the fire was completely contained with F500 at 3% in just under 20 minutes. I'm going to tell you a little bit more details about the testing, but if anybody wants the testing criteria, they reach out to us too, and we'll help you through that data. But the testing configuration was set up alongside of an evacuation corridor. So to the left of that elevated vehicle, there's another space, and they determined that was an empty parking space or an evacuation corridor. So we're looking at public safety primarily. So it was a 50.9 or 51 kilowatt hour battery, basically. It was a lithium-ion battery. The temperatures reached a height of 244 degrees Celsius before extinguishment began. So there was some pre-burn time to make sure it was in thermal runaway. And in the testing, the adjacent vehicle didn't suffer any significant damage. The mirror was burnt, the mirror was melted on the outside. The paint was blistered on the outside, but the vehicle next to it never did catch fire. So to meet approval, the fire protection system had to meet 6 parameters. The battery must be brought to a 90 to 100% state of charge with it, which it was. Thermal runaway had to be confirmed at 6 minutes, which it was. And then the deluge system had to be activated manually at 9 minutes, which it was. The evacuation corridor temperatures could not exceed 60 degrees Celsius, so survivable. The fire could not spread to the adjacent vehicle. It did not. And the temps at 2.5 meters down from the ceiling could not exceed 70 degrees Celsius. So the mock-up temperature for the level of a typical parking garage ceiling, and they wanted to assure that the temperatures would be compatible to life. So a human being could stay below those temperatures, escape through the escape corridor, survive the situation. It passed those tests. So this system, because of that testing by Applus, is now an internationally certified system by ETI. The extinguishing agent, again, was 3% F500. Got several other parameters on the testing. 37.5 meter square meter space, or that was the 3 parking spaces together. A working flow rate of 250 liters per minute, so around 60 gallons per minute. Working pressure of 3 bar, or around 45 psi. Operating time 60 minutes for the system, but it was actually stopped earlier than that because the fire was essentially out. The proportioning system was a diamond doser by HCT, which we'll talk a lot about that as we move forward. Sprinkler nozzles in this case was the Tyco D3, 2 nozzles per space, and they are a deluge nozzle, which is very important when we're talking about lithium-ion batteries. You have to be able to knock down those vapors, absorb or encapsulate those vapors in a situation where you have a vapor only thermal runaway. If you don't do that, you could potentially have an explosion in that space and knock out the sprinkler system. So it has to be able to deluge, not just a closed head sprinkler system. Water requirement was 14.6 cubic meters. So this system was then recommended by DEKRA. Quote from them: special risk requires special measures. The use of F500 EA and the special risk of storage and or use of charging lithium-ion batteries is possible option permitted under German building law to cover this risk. Although classic sprinkler technology or the use of foam agents does not cover this risk or does not cover it adequately, fire tests carried out in accordance with NFPA can also be used as proof. So DEKRA recommends F500 EA for the use in fire suppression systems to protect lithium-ion battery hazards following APLUS's approval. This is a little bit of time-lapse videography here, so it advances faster than the 45 minutes that it actually ran. But as you can see, the F500 is keeping the vapors down, keeping the visibility up through that escape corridor, keeping temperatures down and survivable. Also, it's not impacting the concrete structure. You can see a battery discharging there and rocketing off as typical lithium-ion batteries. So there was successful containment after just 20 minutes, no spread to adjacent vehicles after 60 minutes. Plenty of time for firefighters to arrive on scene and make a difference, potentially with a little bit more F500 directed at certain parts of the vehicle. So this is the commercially available ELATEX system because of that testing. I'm going to pause it here. You have triple mode detection here. So you have photo detection, you have rate of rise detection, as well as smoke detection. So we're catching it a few different ways. And then as you'll notice, it is a deluge, not a closed head sprinkler system. in the next video, you're going to see an actual application used in Madrid, Spain of this system on their mass transit system, where they were going with zero footprint uh, uh, mass transit system in their city. This facility houses and charges over 100 city buses. I thought it was a video, but just a slide. Excuse me. Anyway, as the EMT Madrid is called, it's their mass transit system. They also put in a facility or a depot for these EV buses. And as you see, the red objects above the buses, those come down onto a bus bar on top of the of the of the of the bus itself, charges the bus, but there's a deluge system right above that and immediately built into that charging system as well. So our proportioning system with the Diamond Doser and F500 encapsulator agent is incorporated into this actual application. Again, you can see those heads above them. Those are the actual charging bus bars that come down, make contact with the bus to charge the batteries, and it's all done safely. So you'll notice that's somewhat of an open air environment. Each application is different and needs to have some design specifications obviously applied to it. So that's where a fire protection engineer, our engineer, our support engineer also assists to specify the right type of system and specifications to make sure that it's done correctly. I think this is the actual video. This is the actual video. All right, let's talk next about South Korea. So FES Solutions is a company in South Korea that's comprised of specialists in engineering and fire protection. A few months ago, they had a devastating fire at the Aerosol plant that killed 23 employees initially, and from our understanding, some more had died even after that, unfortunately. So they sought to partner with HCT on some full-scale EV testing with the end goal of developing a revolutionary water mist system equipped with the Diamond Doser as a proportioning unit and an F500 encapsulator agent as well. So at the time of the incident, Aerosol's factory stored close to 35,000 battery cells on the second floor. That was the site of the fire's inception or origin. The flames spread quickly as the combustible metals were used in lithium-ion battery production. They can generate explosive gases, especially when the plain water of a sprinkler system gets sprayed on them. Firefighters did resort to utilizing sand in an attempt to contain the blaze. Ultimately, ribbons were tied in remembrance of the 23 lives lost, unfortunately. This facility housed manufacturing for primary lithium batteries. A primary lithium battery is the earlier type of lithium battery that you might have found in uh, uh, a camera, for example. So they're not rechargeable. A secondary battery is rechargeable. So a primary battery is lithium metal, whereas a secondary battery is lithium ion or uses uh, uh, lithiated electrolyte in the process. So the manufacturing is somewhat different. The components are different, but a lot of the same hazards. So as far as our partnership with FES, we did electric vehicle fire testing at their Fire Protection and Testing Research Institute under the Korea Fire Insurance Association to verify the performance of F500 encapsulator agent. The test featured a Kia Ray EV, actually several of them, equipped with a 16 kilowatt hour battery. At the time of the test, the battery was at 100% charge and brought into thermal runaway by heating with a torch. So as far as the results went, FES solution extinguished the fully involved fire in just 5 minutes, and that not only included the lithium batteries, but also all the synthetics in the vehicle. After a pre-designated pre-burn time, it was a 3% solution of 500 EA. The EV's battery contains 16 modules with 5 cells. Following the testing, the status of each module was evaluated. A total of 4 of the modules were completely burned up. A thorough inspection revealed that 4 modules had normal voltage remaining, and the remaining 8 could not be measured due to the structural damage of the modules themselves. Not uncommon. As a result of this, following the F500 successful performance, FES Solution intends to meet with South Korea's governing body to propose new legislation, codes, etc. Now, some incidents have occurred here in the U.S. Mostly on the West Coast. For whatever reason, they're getting a few more instances of this. So in Nye County, Nevada, they actually started preparing for this. So there's some EV manufacturing that takes place in Nevada, so they wanted to be prepared. So the fire department in Nye County had the opportunity to obtain innovative firefighting equipment and training thanks to a grant funding from the Department of Energy. And they had been working on that for years and years. They were able to get some trailers and some agents for their stations and some training out of that grant. And because of that, they were able to extinguish an incident where there were 31,000 pounds of lithium ion batteries as cargo. Right, this should start. Doesn't seem to want to start. Anyway, he puts the tires out. So it shows their training and testing. So, but this resulted in actually a positive outcome. So over the summer, there were 2 interstate collisions in California that led to some controversy over ground transport practices while hauling batteries. In July, a crash involved a truck loaded with lithium-ion batteries that shut down Interstate 15 in Southern California for almost 2 days. There were many people stranded on that highway in the extreme heat without water or food for those 2 days until they were able to get that problem out of the area, that hazard out of the area, and enable traffic flow to start again. In August, firefighters deployed 50,000 gallons of water, battling a blaze sparked by a Tesla semi on fire on Interstate 80 up north in California. But due to the preparation that was done in Nye County, Nevada, there was an incident on US Highway 95 in Nevada near Mercury. According to the authorities, the 2 semis were involved in a sideswipe collision going opposite directions. One was hauling lumber, the other one was hauling 31,000 pounds of lithium-ion batteries. Those batteries started on fire. Close to about 2 hours later, and with 5,500 gallons of water and F500 EA solution, that fire was brought under control by 2 a.m. The incident happened about midnight. The fire was brought under control around 2 a.m. So it took around 2 hours was all to bring that fire under control. Much more similar to the old days of vehicle fires. So it brings it back down into a manageable incident, not one that lasts days, not one that takes thousands and thousands of gallons of water and long times on scene. It did require some extensive cleanup, of course. A little picture of the next day of all those batteries laying around, some, burnt up and some still probably intact. So they had to do some careful debris removal to pick up the batteries that still had stranded energy. I'm not going to try too hard to pronounce that name on this slide because I'll just mess it up. But in the Faroe Islands in Denmark, the Smeril Ro-Ro ferry is operated by Strandfaraskip Landsens, the largest ferry in their fleet. The vessel holds 200 cars and 975 passengers as a ferry to transport people daily. Makes 2 to 3 trips a day from Tórshavn to Krambatangi. To finalize their upcoming IHM report, the Smeril is welcoming a Diamond Doser fire protection system powered by F500 to advance their fire protection needs. And last but not least, we've talked a lot about the Diamond Doser. So the Diamond Doser is a water-driven proportioner. It installs into the sprinkler riser itself. It can install in new risers and or be retrofit into existing risers with a bypass. So it comes in it's available in multiple diameters and percentages available to meet the need of the hazard and the situation, up to a 10-inch diameter. And then if it needs to go larger than that, you can go tandem, multiples, etc. So we've got the Diamond Dosers to fit your needs. Several miles are FM approved and more are getting approved all the time. And it proportions very, very accurately the F500 and EA into the sprinkler or deluge system, because if water flows, it turns the water motor at a given velocity, and then it proportions in the F500 very, very accurately into the water stream. So if water flows, so does F500. So that's kind of the end of the slide deck. We would sure like to entertain your questions at this time. I'm going to pull some of those up here, and if you have any more questions, be sure to put them in the chat. I don't see the Q&A on this one, Heather. Is there another? Oh, there it is. There's a Q&A section in your chat as well. So I've got a question from an anonymous attendee. Parking structures in very cold climates often have electric outlets for engine block heaters. These can be used for EV charging. They are normally available at each parking spot. I wonder if this situation could be more problematic than limited EV charging stations. It very well could be. There's actually, if you look at YouTube, you can do a search for parking structure fires, and you'll eventually come to it, I'm sure. But there's a Polish fire protection engineer who does a very, very good talk on the hazard of parking structure fires where EVs are involved. And, one of his biggest points that he makes in there is not only the structural difference between ceiling heights and things like that, and the effect on smoke and fire spread, but he also really talks about, you really can't control where people park their EVs. They can be charging or not. And if you look at EV Fire Safe, they have statistics out where plenty of them start on fire that are not charging. So they don't have to be charging to start on fire. And most people, I would imagine, charge them at home, driving to work, charge them back at when they get back at home. So, but they park wherever they want. and there's no real good way to police where they park. We do know of an insurance company that was in the news a week or two ago that made sure that all their employees do not park their EVs in their parking garage, and they're taking their EV charging stations out. So there's some work to be done on that yet. In freezing climates, for example, you'd obviously have to go with a dry system, not subject to freezing. It does take time for the agent to get to the heads, even in a deluge system. So that's always a design factor that you have to deal with. Um, Next question, is the system compatible with dry sprinkler systems? It is. Again, the Diamond Doser just is placed in the riser room that's climate controlled. And then when the agent starts flowing, or excuse me, when the water starts flowing, so does the agent. So again, hopefully it's designed in a way that it takes as short a time as possible to get to the deluge heads. That delay in a large system could be significant. You need to make sure that short. Fires in EVs and lithium ion batteries do develop very, very quickly when they want to, and we don't have control over that. Even in a manufacturing environment with a low state of charge, we don't have control over how fast these fires develop or what the circumstances are that cause them to develop. So, but the Diamond Doser is compatible with dry sprinkler systems. Next question is, can you discuss the effectiveness of F500 in BESS units? Have there been any testing on this hazard? So we've developed some preliminary designs and actually done some manufacturing, standalone manufacturing per unit, per rack, I would say. So F500 is extremely effective on lithium-ion batteries. We've known that for years and years. What our design approach is to the BESS units is we need to get spray on each battery tray. So if you think of a BESS unit like a server rack, a rack with a bunch of trays, each tray has some batteries. Those batteries are interconnected to make enough of a current flow and power over time. But we need to stop these fires as soon as possible so that they don't grow out of control in seconds. So we need to get the agent on each tray. And then because of the NFPA standards on passive fire protection between each rack, we need to get sprinkler protection for each rack and then for the overall unit itself. So it's kind of a triple level of redundancy. So tray, rack, unit, and we make sure we cover all contingencies there to keep it definitely to the unit level. But some of these units are inside of buildings. So if you think of a data center and where the UPSs are located and so forth, it's inside the building. So some design considerations need to be taken into account there. Some UPS units that are going in data centers have an open ventilated top, so it's fairly easy to get F500 into the BESS unit, but we have to do some plumbing inside of the unit to get it down to the tray level. And some manufacturers don't like you to put things inside of their BESS unit or their enclosure. So there's some things that have to be worked with there from our engineering support team, as well as the manufacturer of the BESS unit. But we have designed for some BESS companies and they have accepted our design. Okay, what is the higher density of sprinkler protection for parking structures? So there's three hazard classes. NFPA has their three hazard classes. Factory Mutual has their three hazard classes. They were at a specific hazard class before in both. They both went up a hazard class from a 1 to a 2, for example. I can't remember the numbers right off the top of my head without looking at that specific information, but they both went up a level. So you're looking at about, I believe it's 2 GPM per square foot. But again, it's something that if you inquire, we can get you the specific numbers on those. Um, uh, GPM per square foot, sprinkler density that is needed. And again, there's design factors and all of that stuff and parking density and what's going to be parked in there and how close and how many cars and what's the ceiling height and all those things need to be taken into account. So as long as, and our general approach to sprinkler system, deluge system protection for any structure is that we go with the mandated or tested sprinkler density for um, public safety and, to protect the structure if that's what it's designed to do. And then adding the F500 is just going to make it that much more effective and save more lives. It was mentioned that F500 can limit some smoke toxic gases. Is the F500 considered non-toxic for people breathing or swallowing the F500? Good question. So, yes, so it encapsulates the carbons and hydrocarbons in the vapor space above a fire and or as it's applied to a fire. And I'm gonna share a screen with you so that you can actually see what it does. I'm gonna go back a little ways. I'll actually get out of the slideshow and go to the specific slide. So this was the testing that was done in Nye County, actually the training, not testing. So you're going to see them attack a pile of tires, and you're going to see that black smoke coming off of the tires. And then as soon as that 500 hits it, you're going to see that black smoke disappear.
We're currently at the Nye County training facility where we did several
I don't
live
think the
fire
video
demonstrations,
slides, Dan.
our classroom studies where we went over all the benefits for F500.
Pardon, Heather?
Oh, sorry, we're not seeing the video. We're seeing the desktop.
Oh, probably got to do a different screen here. See if I can pop it out. I'll do one of our others. Let me pull up something here really quick. Apologize for the delay. I'm navigating. All right.
So now, yeah,
You able to
you can
see
hit that
that?
whatever you want. Good.
All right. Were you able to see that?
Yeah, we're good now. Thanks, Dan.
Okay. So as you see, the extreme black smoke coming off of the pile of tires.
So
There's the
now,
F500
yeah,
hits it.
you can hit that whatever you want. Good.
The smoke is gone. You have some water vapor there. Not steam, not scalding, very comfortable. The toxins, the free radicals are encapsulated inside of the spherical micelles, and it's actually pretty comfortable to breathe. Now, we, pretty variable on where you're exactly standing in that, but it really takes a lot of the toxins out of that cloud and the smoke and interrupts the process of the creation of those toxins in the first place. So it makes that off gassing from that uh, uh, combustion situation that was occurring seconds ago very, very much more safe. Now, safe is relative and depends on where you're standing and all of that, but it does make the atmosphere much more safe, much less toxic than it was seconds ago. We still always recommend firefighters wear self-contained breathing apparatus, but if you're a victim, your situation just got much, much more survivable. When it comes to, I think you mentioned actually ingesting the product. We've got 25 years of testing on uh, toxicity, etc. And it actually was tested on 20 rats. Those rats, it was ingested for a week. It gave them all diarrhea. Then they got better once it stopped. So it did not cause them to die or anything like that. So it passed skin irritation tests. It is like any surfactant, somewhat of an eye irritant. There's an environmental standard within NFPA 18A. It passes that as well. See, get my reading glasses on here and see if there's other ones. Okay, I think that was the last question in the Q&A. If there's any more, be sure and type them in. I am going to look and make sure we've got the questions out of the regular chat, if there are any more. Ken or Victor, who would be the ETS for Texas? Engineer for the state fire marshal is requesting. We've got the email address on that. We'll be sure to get you that answer. All right. Well, again, we thank everyone for participating today. If you don't have any more questions, be sure to reach out through our contact form on our website. We have got an extensive e-library on there showing the actual effects of F500 on all the different classes of fire. There are really no contraindications to the application of F500. You know, if you think about combustible metals, combustible dust, all the potential water reactives, we have not really found a situation yet where uh, uh, especially at 3%, F500 has any kind of a reactive effect with fire that water would. So it's pretty safe overall, all hazards agent. You know, when we're talking about sprinkler and deluge systems, um, we look at it from an engineering standpoint. We work with sprinkler and design installation firms on a business-to-business relationship to help them with their clients' problems and make sure that we're providing the correct engineered solution for their particular situation. So if you have any questions, be sure and reach out. We've got representatives all over the world that can help you in engineering support in our main office as well. So be sure and reach out. And again, thank you, Heather. Thank you, everyone, for participating today, and have a safe day.
Thanks, everyone.